So this is Discovering the Beauty of Tech Debt. My name is Daisy Galvan. I'm a software developer at Facebook Dublin. So I'll be sharing a story with you about my journey refactoring one of our services. And sorry, I just got really nervous. So sharing a story with you about my journey tackling some tech debt to improve our discovery service. And before I get into the good stuff, let me give you some context. So discovery, it's an internal service that we use to discover hosts on the network and retrieve data on them. Some of this data includes the device's image software, its port address, management IPs, plenty more. And then this data is shared with other services and used to update the database. But ultimately, this all rolls up to help us understand and monitor our network topology and the infrastructure, which is important, right? So the thing with discovery is that over time, it became this huge file, and it was super messy. It had had conditions to take some steps and avoid others. Kind of what you see going on there with those if-else ifs. And I'm sure everyone here knows what I'm talking about, where you have that one file that if you need to modify it, you just kind of cringe, or sometimes drives you to drink if you have to modify. And if that is the case, well, there's probably some tech debt going on. And for discovery, that was definitely the case. And if you're curious to know what tech debt actually looks like, boom. Not a good look, right? So needless to say, discovery was more than ready for a makeover. Now, this is where I come into the picture. And I don't actually wear bows, but I didn't want my stick figure to look like a boy either. So, now for myself, in my day-to-day, I actually work on a team called Community Operations Engineering, where I build internal support tools for the CO org specifically. But I have an active interest in infrastructure. And the cool thing is that at Facebook, we have this program called a Hack-a-Month, where you can go work on totally different teams, something completely new, and whatever you guys decide. And that's what happened in my case. I went out to California for a month, and I worked on an infrastructure tooling team. And that's when I met Discovery. So, like I mentioned, the thing with Discovery is that it had a series of ifs, else ifs, all over the place. And these conditions, they were based on the platform OS type. And you can imagine with all the different platforms we have out there, Cisco, Junos, etc., the code just became very nested and unreadable. There was a lot of shared functionality between these different platforms as well. So at the end of the day, you were bouncing up and down the file just to get an understanding of what was going on. And I spared you guys with just one class example, but trust me, it was bad, and it made me sad. So yeah, we could have continued the hacky way with these if-else-if patterns, but easy isn't right. And instead, we decided to embrace the engineering excellence motto and tackle the tech debt. Or take it apart. So, what we decided on is a combination of OS class mapper with a factory pattern. What this did is it gave us a structure and class hierarchy to design a cleaner service. The data sources became the class functions themselves, for instance, like Junos discovery, or blah 0 in this case. And then the data sources themselves, such as management IP, was the get management IP address. Not to mention the readability improved, which is great. But the real impact is that by refactoring the service in this object-oriented fashion, we not only improved the service integrity by discovering some data gaps. For instance, maybe a platform was missing the port far end. So that was one big win. A second big win is that we designed it to scale for the future. Now we could easily integrate new platforms. Not to mention at Facebook, scale really does matter. And it made me happy, so there's that. So 30 diffs later, 30 diffs later, Discovery became beautiful again. And in case you've been spacing out these last 5 minutes, I'll conclude with this. Yes, tech debt is a bitch, but it's a great opportunity to learn, to create something beautiful, something you're proud of. And you may even get to do a hack-a-month out of it. Thanks.
And next up, we have Will from Google, who's going to talk about incidents in Lego. was a spoiler. Hi, I'm Will Nowak. I work at Google. I'm going to talk about doing an incident management simulation with Lego. So, why would you use Legos for incident management? Let's see. Last year, I had the task of playing an activity for day 3 of our team summit. Late in the afternoon, when everyone's tired, they didn't really want to learn anymore. And we're going to teach incident management to those people. Ideally, it would be an offline thing because it was a random hotel, internet access is crappy. And we wanted to let people simulate the overload of being in an incident without actually breaking anything. So what we did is we put together this simulation exercise. They were new employees in a company. They had to handle an outage in a system they had never used before. So some of the tasks we put together. To simulate background noise, I embraced my inner youth and I got some crayons, went to the Crayola website, printed out some coloring activities, and simple noisy pages were, please color in this worksheet. It worked out pretty well to keep everyone busy on the teams until things really went wrong. It also had the bonus of creating some pretty cool artifacts like this that people got to hang up in their offices. Also, we wanted some things that were a little bit more complex. So once an incident was actually underway, we broke out some cards and had 2 people play Go Fish to simulate master election. I don't know if you've ever had the displeasure of playing Go Fish with 2 people. It takes a really long time. It's painful. It's a great way to take 2 people out of commission for a while. Full disclosure, not everyone knows how to play Go Fish. So if you're putting together an activity like this, I highly recommend putting together a team playbook packet with some instructions so people don't feel left out. All right, dashboards are not always good. In this case, I wanted people to feel the pain of going through a capacity dashboard they had never used before. So I got some baby food containers and a big bag of multicolored beads from Amazon. And I told people that red was CPU, green was RAM, and blue was disk. They need to count how many were there and let me know 10% more because this outage can only be resolved by doing that. This also let us exercise some cross-team communication with a highly technical communication device called Paper. So here they had their various resources and the number they needed. To help people feel better about this exercise as well, we incentivized them with candy. We had a team from Australia and a team from California, so we brought some treats from both places to act as the resources they were getting. So to turn up capacity, these Legos are great. They're on the order of $5. Don't buy this one in particular. It's a little too easy. But the 100 or so piece collections are great. They take someone around 10 minutes to build. So it's a really good way to have them simulate the process of doing something that they'd have to read a manual and spend a lot of detail-oriented time working on. The model that we actually went with was a little car, and to test the capacity, they had to be able to roll the car. So give that a shot. It works out really well. So some takeaways from this. Definitely spend some time making training fun. I probably spent more time than I should have putting together the activity. We had the team packet with some simulated corporate BS to let people know about the synergies they should be creating by working on this product. Get people sort of in the mood for the training they should be experiencing without boring them to death. Make this memorable. This was one of the highest rated activities we did over our multi-day offsite. Letting people get involved in something and remember what they did to apply later to the actual problem was super helpful. Get the new people on your team and the tenured employees on your team working together. We had tables mixed up of people who had been through live production incidents and people who it was their first week at Google. And getting those people together, we could let them interact and understand when it was time to hand off one of these painful Go Fish exercises to a different member of the team so they could get back to working on communication. And don't be afraid to repurpose things you have lying around. I'm sure baby food containers were never used as capacity dashboards before, but I think it was a pretty cool use of stuff. If you have questions about this or you're looking for some more visibility into the really questionable sample content I put together, I'd be happy to chat. will@google.com. Thanks.
All right, and next up, we have Kyle from Facebook talking about deploys.
Guten Abend, everyone. I'm Kyle. I'm from the production engineer on the traffic applications team at Facebook, and I'm here today to talk to you about how we tamed our deployment process. So you might be asking, like, what makes our deployments unique? The simple answer is our scale, not in terms of the numbers of servers that we deploy to, but in terms of the numbers of installations. At Facebook, most teams deploy to our data center locations, which are on the order of 10 or so. Traffic, we deal with our points of presence, which you can assume is an order of magnitude more. And we also have our global caches, which are another order of magnitude above that. So the tooling that we were using was designed for 2 orders of magnitude less than what we were doing. And we wanted a way to improve the tooling, but not actually need to go and support it. So this is what we ended up doing. So to just kind of walk you through our deployment process, in the morning we'd come in, choose the latest CI binary build, and canary that. This would generally take about 4 hours between canarying to the hosts and bake time to just see if anything goes wrong. So the first thing that we did was automate the steps that didn't require human judgment. You notice I said we just took the CI build. That's something that can be a cron job or Jenkins or Lambda scheduled event. Not something we have to think about. So that shaved 4 hours off our deployment process right there. So the next step was deploying to 5%, in which case every installation that we had around the world would get at least one machine running the new package. Now for our points of presence, not a problem. They had pretty good connectivity back to our origin. But for our global caches, some of them are deliberately in locations where we don't have good connectivity. So now the engineer was tied up waiting like 2 or 3 hours waiting for these slow caches to get it before proceeding past the 5%. So what we ended up doing was creating a shadow job to get packages on the machine early. Now, Kubernetes terms, this would be same node selectors, same Docker image, but having an entry point of literally bin sleep 1 week. What this did is get the packages that we needed into the machine cache, and important, because again, this doesn't require any thinking, we can run it with the canary job the night before. So at this point, we've kind of saved a bunch of hours. In the normal deployment process, this would be like, okay, 5 p.m., we don't want to continue the deployment into the night, so we would stop here. And admittedly, this is where the bulk of the 32 hours is coming from, that waiting period, where we'd pick it up the next morning and again have a long tail. Now this long tail comes from machines that would just, for some reason, not get the update. Tiny fraction, but at the scale we're working at, again, remember, more than like literally thousands of installations. 2 minutes, okay. Literally thousands of installations. The small portion of it is like literally taking hours of engineer time to go and fix. So what we ended up doing here was we took the symptoms that we saw, bucketed them, and tracked them over time. Then we determined the most frequent problems that we saw, root cause, fixed them, repeat, essentially driving this down over time. Now this had 2 advantages. One, we had quantifiable numbers that we could go to our manager and say like, hey, these numbers, these improvements justify the engineering effort that we just put into this. And the second thing was, it also gave us numbers to prioritize. And at the end, it's like when you have 1 or 2 systems that were showing whatever weird, strange cases, we were able to say, yeah, the engineering effort required to fix these isn't worth it. We can just fix them as and when they occur. So finally, it's important to remember, none of this was done overnight. Our deployment cadence was weekly. Every time we deployed, this was an opportunity to go and like fix problems, inspect our process, and refine, and repeat. So hopefully your deployments happen regularly as well. Every deployment process that you go through is an opportunity for you to improve. And hopefully these 3 tips given you some ideas for your own deployments. Thank you.
Next up, we have Dom from Improbable talking about Thanos.
Hello. Okay, so I'm talking about Thanos, an open source project from Improbable. This is me. I'm a software engineer in infrastructure working at Improbable. And our mission is to make impossible games possible by creating a platform as a service where we take care of the distributed back-end systems for games, whereby game developers can concentrate on making it fun. So we started off with Prometheus to gather metrics in our platform and on the games. We quickly figured that Prometheus didn't meet all the needs we wanted. So we created a project called Thanos. Thanos aims to get a global view of all metrics from a single entry point, long-term storage and querying, and high availability. So we'll start off with global view. To make a global view, we attached sidecars to Prometheus. These sidecars have gRPC endpoints where you can call, and that literally proxies into Prometheus via the remote read API. From here, we can use another component of Thanos, whereby it calls into each sidecar, and this then merges the results into single time series that we can then display from a single entry point. So here you can see a query across a number of clusters from one UI. Okay, long-term storage. The other thing that the Thanos sidecar does is monitor when Prometheus writes blocks to local storage. When it does this, we upload that to the object storage in GCP or AWS. In doing so, we can actually reduce the retention period on disk so that Prometheus only needs to know about 6 hours rather than the normal 6 weeks. However, this becomes a problem because we can now only query the 6 hours that's held locally on Prometheus. However, we thought about this and added a new component into Thanos, the store node. So now when the querier needs to query, it gets the first 6 hours from the sidecars and Prometheus, and the other data from the store node and object storage. It then again merges this data together to make sure it returns a single time series to the user. Now you can see we have 12 weeks worth of data. 6 of it was from the Prometheus instance, the rest was from object storage. High availability. This was done by deploying replicas of Prometheus scraping the same targets. These targets were then uploaded to object storage as well. We can see here that we actually merge and deduplicate on the query component as well. This means that we can send less data back to the user and fill in gaps if any deployments failed. Here you can see a graph of a number of components. This is actually duplicate data. We can also show this to the user in a deduplicated manner. So now that we have HA Prometheus, we don't miss metrics when we deploy or when one of the nodes fall over, and we upload that to object storage. We can also easily make the query and the store components HA just by using Kubernetes services. Now most of our system is HA. We've got a lot of data being backed up in global storage, and we can query for a long time. However, this does mean that we have a lot of data. So what we eventually do is have this compact component which will look at object storage and reduce down the time series and do deduplication for us. Once this has been done, we can actually run much smaller Prometheus installs and serve most of it from the object storage, which is now compacted down. We also added downsampling to the compactor, so we can choose a resolution based on the query you're doing. We can auto downsample or allow the user to select this. The query component actually surfaces HTTP APIs, which means that it can be put behind something like Grafana that you would normally use. So a lot of this fits into your current setup, just with adding new components to give you those benefits. This is Thanos, Prometheus at scale. So we've seen that we've got a global view, long-term storage, and high availability. It's all open source and on GitHub, so you can install it yourself, add some issues and queries about what's happening, and we can work together as a community to make Prometheus even better. Come and speak to myself or anyone in one of these Improbable t-shirts to learn more about Thanos and how we've deployed it. We're also hiring, so check out our website. Thank you very much.
Next up, we have Stephan from Blue Yonder talking about SLA-driven container updates.
Yeah, so hi everybody. I'm a I'm a Apache committer by night and Blue Yonder employee by day. And what we do at Blue Yonder is that we solve problems for retailers. So they want to know which product they're going to sell in which location at which day. And specifically, they want to know how much they should order so that at the end of the day, they don't run out of stock, but also that they don't have to throw anything away. And kind of the important bit is here that we need the insight of good predictions, but we also need the fully automated end-to-end decision. So kind of we need to take the human out of the equation because he might not order what we tell him to order. That's kind of like what we focus on, but in my normal kind of like engineering work, I'm mostly just concerned with the insight. So for example, this is a graph, and the graph provides me the insight that I have messed up because it shows that we kind of like missed our SLOs with some clusters because I've done maintenance faster than I should have. So I've taken down nodes that actually should be running. And kind of like the human, so me, is still part of the equation. But the good thing is that that's now kind of been fixed. We're using Apache Aurora, which is a Mesos framework for long-running services, cron jobs, and it's mostly run at Twitter, but also other companies such as PayPal. And two Twitter engineers has recently added in a pretty interesting new feature, which is if you see the job description on the left, so you can specify that's like normal, how many instances you have, what code they're running, what container. And the new thing they added is that you can also specify SLAs. So you can describe when your scheduler is allowed to take down an instance. So we can, for example, say, please always have an uptime of 99.5% and never decide to take down an instance if you would go below that limit. And you could even define like a coordinator that it's being called into by the scheduler to actually decide if it's safe to take something down. And they kind of leveraged this for two interesting features. The one is SLA-aware maintenance. So they can now drain nodes, but only as fast as currently possible without affecting the jobs running on it. So that gives them time to run, let's say, storage services, maybe even some that are kind of aware of where the data is located. And it's kind of safe to do this. And the other interesting feature is that they now can do SLA-aware updates, which means that if you have a rolling update that updates all of your instances of your service, that can now also consider the SLA of your service. So, for instance, if this update is running at full pace, but suddenly some racks in your cluster fail, and you do maintenance at the other end, the update will automatically slow down so that your overall uptime SLA is still being met. And that offers some pretty great possibilities to kind of simplify the operational model, because suddenly you don't just have the insight that these are your uptime SLAs, but you also have the automated decision that something is actually driven by it. And that's kind of the gist of this talk. So kind of like, as we've seen before, don't just be fine with having insight, with having awesome dashboards, but also think ahead how you can kind of leverage this to fully automate kind of your job away. And yeah, if you have any further questions, please come to me. If you want to talk about how to order bananas, or if you're interested in Apache Aurora, just come to me. Thank you.
Well done.
Next up, we have Effie talking about hiring and being hired, and jobs, employment.
Hello, I am Effie, and I'm an SRE from Athens, and this curious talk is not about how to land a great job or how to find perfect candidates, but it's about what we're afraid of when we're in the hiring process. So this talk appeals to people who are not very experienced in being interviewed and being interviewed as skilled, to young organizations that they're just building their hiring processes, and to people who just started interviewing other people. And disclaimer, I am not a very experienced interviewer, so I interviewed a few interviewers about this talk. So the first thing we're afraid of when we're candidates, it's the cover letter. And the worst part is that when we begin our careers, we don't know why this is important. You have to know that when we are on the job, we are required to write emails, to write comments, to documentation. So if we're able to write a presentable letter about what we like, what we've been up to, we're going to be able to probably do all the above as well. Next, we are having a hard time saying I don't know, and our imposter syndrome does not help us at all, and we completely forget that no one knows everything during that time. And the last one is my personal fear. I'm really scared when the other person is not moving any facial muscles, so it completely throws me off. So next, when we are on the other side, single word answers, we're hitting a wall when the candidate is just saying yes and no. But we're hitting a bigger wall when we realize that what's on paper does not reflect the reality, and we're just wasting our time here. Next is also very hard when we like the candidate very, very much, but realize that their technical skills are a bit below par. So we feel guilty for making someone really, really miserable. And lastly, hidden red flags. After the course of interviews, we may fear that we missed something on the personality level. We may have missed that the other person is a racist, a sexist, or doesn't even like talking to people. So both sides have picked up some annoying habits over the year. We have all read a long list of absurd requirements, and technical or non-technical ones. I think my favorite one is out-of-the-box thinker and team player, because no one knows what they mean with those two requirements. Next, there are the unwritten requirements, as the ones that we can't know, because maybe what they are looking for is of certain ethnicity, sex. And then there are the free-for-all interviews, where we have 3, 4, maybe more interviewers in the same room, and they are all free to just have a go at the interviewee. When we are applying for jobs and we go through the interview process and no one calls us back to tell us what happened in the end, it's one of the worst parts, and I think anyone who walks through our door deserves to know what happened. Lastly, when we make an offer and the candidate decides to stay at their current job and we feel used so that someone can get a better paycheck. On a final note, before you make people jump through hoops to get a job at your organization, you have to know where you stand. And it's a competitive market, and it's easy for someone to say, this is not worth it. Next, never underestimate the word of mouth. People talk, so an unpleasant interview is not going to stay in the room. It's going to be discussed by both sides. Lastly, this is for young organizations. I know that when we're in a small org, we are trying to keep our people to hire people that they're into our culture and stuff, but we have to keep the whole team in the hiring loop. If you hire those people, you trust them, and this trust should not be limited to only the technical decisions. And that'll be all.
Next up, we have Vlad from Infrastructure as Code talking about how we can improve our alerting.
Hi, I'm Vladimir. I'm an infrastructure coder or ops dev, but you can just call me site reliability engineer. I recently started in a new project, and then I thought, this time let's do everything right. So let's monitor for symptoms, not for possible causes, like Google SRE book told us. But what I've found on site was Zabbix, 15 old years technology. Who knows Zabbix? Okay. Who still uses Zabbix or Nagios or Isinga or some other older technology for monitoring? So not everybody switched to this fancy services, web services yet. So unfortunately, Zabbix was designed with hosts in mind and not very well suitable for a microservices landscape. But it was already set up. It's already integrated into the organization, like connected to mailing list, instant messaging, and so on. And it has got very good performance. So once you add your hosts to Zabbix and assign default templates, you get plenty of monitoring items and triggers. For example, like checking if VM is still reachable per ICMP ping, or is it still reachable per SSH. So here we added some more, like application health. So it checks if application is still available, and all the dependencies of the application, like database and message queues, are reachable. So then if we look at our 4 instances which implement our service, so you can see when which was available. On the right side you see a rolling reboot. Just before that there is probably some sort of unintended failure. And by default Zabbix would alert us on that. So, but since we added all the VMs extra for reliability and for redundancy, we don't want to be alerted on a failure of a single VM. So then it came out that there is a less known feature of Zabbix where you can create a trigger which references items from multiple services. So here we have a single trigger. It's a very complicated expression which checks server 1 and if data is still available, server 2, server 3, and then aggregates the things and compares it to our desired threshold. So we only get alerted if you have one or more, if you have more than one of the servers failing. This expression looks very complicated. It's also very error-prone to enter or especially to adjust. So we certainly don't want to do it by hand. So this is why we implemented a Python library for that. So and fit it into our Ansible playbooks and lookup plugins, and using Zabbix API to just set everything up once a new host is added. So if you found yourself in an enterprise environment where you cannot fully control the tools you have to use, you can still do the right thing, like monitor for symptoms, not for possible causes. And you just need to try harder. So after the conference, I will upload some of the source codes you can probably use straight in your Zabbix, or just look at it for inspiration and use with your legacy monitoring tool. So thank you very much.
Thanks. Next up, we have George talking about AIOps, deep learning, and time series analysis.
Good evening. My name is Jorge Cardoso. I will then talk about AIOps. I don't have time to go into all the details, but just to give you the main idea of the work we are doing. This is a use case, so our goal is to explore where can you use AI. So everybody has heard about deep learning, and there is plenty of cases where it's very useful, image recognition, for example, and we try to explore it for SRE work. So all the data that you generate, we would like to have advanced, let's call them algorithms that could actually extract insights and just do the work, let's say, automatically if possible. This is a use case with tracing. I think most people know tracing. So the keywords open tracing, Zipkin, and Dapper, Google. Tracing, it's about following a service request and you propagate the context across microservices or across processes, and you can reconstruct this. So when you, what happens is when you do this reconstruction, you get these trace, right? And when this trace is executed to fulfill a service, what will happen is sometimes you have deviations. So you may have latency deviations, you may have errors that happen, and you may have actually new spans or new events that show up in your trace. And if you have an anomaly in your platform, the traces will tell you, because you will have what we call often a mutation of one of those traces. So a trace generates A, B, C, D, A, B, C, C, B, Z, and we analyze all these traces. So this is, again, just to give you the overview, we have our users. They execute instructions into cloud platforms. We are talking about large-scale systems, so planet-scale systems. And all these commands that are executed to create and delete VMs, they will just generate a distributed trace. What usually you do is you visualize the trace and you try to detect anomalies. What we try to do is to have systems to find anomalies automatically, and we just want to be notified if something serious has happened. We take all these traces, so it's quite a few generated per second, depending on the size of your platform, and we encode them with sequences of numbers or letters, and at the end we have a machine that will tell you this trace here has a mutation, and the system can tell you a little bit more than just it has a problem. It can identify the type of problem. We use something called Lsdms. This is technical. This is deep learning. It's a type of neural network. Basically, the neural network is here. It's a set of models, typically matrix multiplication. And here is your span. So your span comes here. You feed it to the network. You have a few X's, and you have the output. Those are the H's. And you'll be monitoring those H's to see if they match those X's. This is a little bit technical, but it gives you the idea that there is a model that will be trained. So this is, again, the training phase. So you feed in this experiment, we feed 1 million spans, 100,000 traces. And this is the training here. So our system just reads all these traces. They represent normality. And then when we go into operations, we sample certain traces that we feed into our machine learning, and it will tell us if the trace that we just saw should be considered abnormal or not. This gives you an idea of the code, just for you to have a feeling, so it's not really to understand. Those are real spans, and they are somehow encoded here. They are real spans. We take them, we encode them into a special structure because machine learning requires these specific instructions. Here you see a model being created, Lsdm, you see here the words, and then you train it. Training is a problem, takes time, it's hard to understand how things are trained. It may take 2 hours to train these 1 million spans if you have a GPU, otherwise it will take you a little bit more. But when the model is ready, you can store it in a hard drive and you can just use it. Here it's being used. Red means that's an anomalous trace, and here green means it's okay. So this is just CLI instructions, so we don't have a nice visualization. It just analyzes the information. Very high accuracy, so this is the advantage. You get to 99.73% of accuracies. It will really detect if something goes wrong. It's really fast after training. So training, it's extremely expensive, but then the testing, it's really fast. I put here some notes that you can go over them. They are a little bit technical, but I hope that I was able to convey the idea of how AIOps, machine learning, deep learning, can actually help SREs. We don't know in all the places where it can help, but slowly we find use cases that work very well. Thank you.
Next up, we have Jason talking about trees.
Hello, I'm Jason, and I'm going to be talking about how at Ecosia, site reliability plants trees. But first, a bit about me. I know there's been some talk about SREs from really interesting, diverse backgrounds. Well, I started off as a jazz saxophonist, And then for a bit, I was an Apple Store genius. And then I moved from Canada to Europe and ended up in Berlin, where I now work as a backend developer focusing on infrastructure. And today I'm going to talk about the company Ecosia, how it works, and how we practice site reliability. Ecosia is the search engine that plants trees. Let me explain. When our users make a web search, we show ads next to our regular search results, just like Google. Every time a user clicks on one of these ads, we earn some money. Unlike any other search engine, we use all of our profits from this advertising to plant trees by supporting reforestation projects all around the world. Wait a minute. An internet startup that's using its profits for good? I mean, an internet startup with profits? A search engine that doesn't care about tracking you? How does this make sense? I've got to be honest, it's really, really simple. We earn money like every other search engine. We use it to plant trees. And we're doing pretty well at it. This screenshot's a couple days old. I just checked earlier. As of this evening, we've planted 36 million trees. And let me tell you, it's really, really rewarding as a developer to contribute to something as worthwhile as saving the planet. Now, whenever you get a chance, we can go to the next slide. Now, I know a lot of SREs are from big mega companies, but what about small companies? How many people here, maybe it's a quick straw poll, how many people here are from companies with fewer than 1,000 developers? Okay. How many people are from companies with fewer than 100 developers? How many people are from companies with fewer than 20 developers? Okay. It makes sense to me, right? Big companies can afford to invest in SREs. But as you can imagine, at Ecosia, all the money that we spend on running the company is money that we don't spend on planting trees. So we're pretty lean. We develop Ecosia Search for our millions of users with a team of around 10 developers, and only 2 of which focus primarily on infrastructure, one of whom is on this stage, and the other one, luckily for me, is currently on call. For the infrastructure-focused developers, myself and my counterpart, we realized that doing operations like throw it over the fence, I can't motion like that. Throw it over the fence was not going to work for us. There's too much to be done between maintaining the platform and being on call for us to also be doing production reviews and writing everyone's deployment configuration. So the solution for us was to embed ourselves in the product development teams. So we split our non-toil work between our infrastructure tasks and quote-unquote normal dev work. We take tickets, we work on the product, which helps us get an idea of what the development workflow is like, but it also encourages us to make our platform more self-service. So we spend a lot of our platform work trying to design a system on top of Kubernetes and other technologies like Bazel and JSONet in a way that enables all developers to be involved in deployments, capacity planning, and postmortems. At the highest level, the company goal is to leverage our community of users to generate revenue through ads, which we use to plant trees. So some of our infrastructure metrics come from business metrics. You know, if the users are searching and if we're getting clicks on ads, we're doing okay. From there, we can derive the main system metric, trees per second. Trees per second. But trees per second tells us if our infrastructure is healthy. That way we can also measure our outages in trees unplanted, and our error budget is also measured in trees. Working on infrastructure can often be so abstract that I find it really valuable to tie our company's system health back to something a bit more tactile. It also gives our developers a lot of pride to see the tangible impact on the environment that our software is having. As an example of how we do this, relating our dev work back to the company achievements, I want to show this short 30-second video from a few months ago when we hit 30 million trees planted. It's really, really amazing to think that the work we do on silly things like platform stability and cloud cost optimization is contributing to this. Any YouTube SREs here? Now, if you're not yet convinced to start using Ecosia in your browser, you can go to the next one, that's the end. If you're not yet convinced, come and talk to me or send me a message. Either we can talk about Ecosia in general, or we can talk about how at Ecosia we're using all the cool technologies like Kubernetes and Prometheus to save our costs, which for us means planting more trees. Thank you for staying right until the very end.